Okay, so let's actually do some examples of this thing where we take a unit vector from a position vector and then use it to direct a force down that. Sounds hard, but it's honestly extremely difficult. No, it's not that bad. Let's get into it. There we go. So here is our problem. We have a 420 Newton force going down one cable and an 840 Newton force down another one. And we want to find the force AC in Cartesian vector form. So this is even simpler than the problem itself. We're not actually doing anything with force B, just force AC. Now you see in the problem statement it's just called force C, but it's trying to tell you like, well, this is starting from A and then going down this line. Okay, so here's how you do it. Go off and conquer with this. Put myself out of the way. So what we want to do is find the position vector and then turn it into a unit vector. You know how to do that. I'm not going to tell you because we learned about it in a previous video. You're going to obtain the force vector by multiplying the magnitude of the force by that unit vector, which is pretty much how you solve the problem. So go and try it. You can do this. I believe in you. I'm going to count to 3. By that point, hopefully you've paused, gone and tried the problem on your own, and then come back to watch the video. So 1, 2, 3. Let's go. I always forget to put my, there we go. So we have this. Now what is our position vector? Well, if we look at this, we have, no coordinate system except for right here. This would be the origin. Now why is that point the origin? Sorry, when I said no coordinate system, I didn't see no origin. But I can see the origin now because it was no longer X is blocked by my picture. So this is where everything starts. So this point right here, that's going to be 0, 0, 0. Now, does that matter too much? It really just depends on how you think about it. What we need to know, though, is how far away from where is this point and then where is this point? Because we need to subtract them. And if I want to, I can make a position vector for each of these. I can make where this position is, I can make where this position is, and I can subtract them. Or you can just think about it. What is your position vector? It is how far you've gone from this point to this point. And we can look at that pretty simply. So in the X direction, how far have I gone from here to here? Well, as you can see, I've only gone 2 meters in the X direction. That's where this 2 comes from. In the Y direction, how far have I gone from here to here? Now on this plane, that's just that point right here. So I've gone 3 meters. That's where that number comes from. And then from here to here, how far have I gone in the Z direction? Well, you can see that. That's right there. But it's 6 meters down. It's -6. It's not a +6. So that's where that comes from. I could have also done it the long way if I wanted to and made a sort of position vector for each of those two from the origin and then subtracted them. So A would have been, let's see, make it the same kind of thing, 0i plus 0j plus 6k meters. B would have been equal to, make sure I, oh, sorry, not B, guys, C. C would have been equal to 2i plus 3j plus 0k meters. I subtract those two. Tip minus tail. So 2, 3, -6. Same exact answer. All really depends on how you want to look at it. Okay, so delete all this. So now we have our position vector. We got to turn into a unit vector. How are we going to do that? Well, what we're going to do is we're going to first find the magnitude of that vector, which means we take each of the components, we square them, we add them together, and then we take the square root. It's just like Pythagorean theorem, but with 3 dimensions now instead of 2. Now that we've had the magnitude, we just use our unit vector equation, which just says I take the vector form and I divide it by the scalar form. Okay, I take the vector, I divide it by the magnitude. That gives me a vector that has a direction, same direction, but it's now its length is 1 and it's dimensionless. And once I have that, I can go ahead and multiply it by the magnitude of my force vector, which is 420 newtons. And I have my force vector. And there you go. That is it. That's all you have to do. Now, hopefully this made sense. If it didn't, go back over, try it again, but do it with this one next time and see if that can help you. If you still haven't gotten it, then email me. Let me know. I will go over some more examples. I'll make another video if I have to. And we'll keep on going through it, okay? Well, hope you enjoyed this. I'll see all of you next time as we try a little bit harder example. Bye-bye.